Hello friends, this is Dr. Mohammad Aslam FCA from Pulse Tutorial. In our previous videos, we discussed partial least square structure equation modeling PLS for mediation model. Today, we will discuss PLS-SEM for no mediation model. Smart PLS software is used for today's discussion. Its setup file with license key are provided in our earlier videos. Today, studies, materials, and dataset are provided with the link for you download and use. You can contact us by email, Zoom, or WhatsApp for any further assistance. The PLS-SEM seems hotcake for social science research recently. It has been used widely in latest article published in high-quality journals such as Web of Science and Scopus because it can deal with multiple variables containing multiple indicators or items for factor analysis and regression simultaneously. It is termed as third generation statistics for social scientists. We emphasize its applicability rather than its technicality and used hypothetical theory and dataset for your easy understanding. Let's discuss the PLS-SEM no moderation model building and reporting with multiple variables and multiple indicators or items in this example. Moderation variable means that it can change the existing relationship between dependent and independent variables. For example, with low job turnover, for example, we get previous literature that high job satisfaction is associated with low job turnover. Appropriate references are required for these relationships. Say, Aslam et al. 2020 found this in their study. But what if job shortage in the market? People may not leave their job even they are highly dissatisfied as there is no available job in the market. Therefore, market becomes a moderator variable between job satisfaction and job turnover. If market cannot influence between job satisfaction and job turnover, then this is the sign of no moderation, otherwise moderation. Now, we want to explore this relationship either to confirm or reject with Aslam et al.'s 2020's aforesaid findings by our own research and dataset. Firstly, we get job satisfaction JS as independent variable observed through JA1 to JA5, where JA1 means basic need satisfaction, JA2 means security and safety, and so on up to JA5. Secondly, we get job turnover as dependent variable observed to JT1 to JT5, where JT1 means obligatory turnover, JT2 means voluntary turnover, and so on up to JT5. In this model, we will discuss moderating role of a third variable between JS and JT. Then third variable we add job market JM as moderator variable observed through JM1 to JM8, where JM1 means government job, JM2 means private job, and so on up to JM8. In PLS-SEM, variables are referred to constructs that are observed or measured through reflective or formative indicators or items. In this discussion, we make our model through reflective observed indicators like JS1 to JS5, JM1 to JM8, and JT1 to JT5 to represent the respective unobserved construct, namely JS, JM, and JT. Let's assume our research is based on primary data. After setting the aforesaid indicators for independent and dependent construct, we need to prepare questionnaire for data collection. Here, we use 7-point Likert scale for respondent score. How to entry data in Excel sheet from filled up questionnaire and then transfer to CSV format for smart PLS data read are discussed in our previous videos. So I am not repeating it. Hope you have seen the videos and practice those working files for your understanding. Now, please open your install Smart PLS software. Interface will appear like this. Click New Project in the toolbox and name as No Moderation Model. No Moderation Model. Then we need to click OK. We'll double click here to import the data we have previously saved in our CSV format. Replace OK. We'll find the newly created project in the Project Explorer. Then double-click data icon to import the data no moderation model dataset CSV file provided with this video. Software will read the data and become green, meaning ready for operation with the dataset and procedure. No moderation data text that showing the report for indicator correlation and raw file. All 20 indicators, age, gender, JS1 to JS5, JM1 to JM8, JS1 to JS5 are shown serially with no missing data. And displaying mean, median, maximum, minimum, standard deviation, access kurtosis, and skewness. Although PLS-SEM is a non-parametric test where no need to assume normal distribution, but even we want to know our data characteristics. We know that perfect normal distribution contains mean 0, standard deviation 1, skewness 0, and kurtosis 3. Acceptable values of skewness fall between -3 and +3, and kurtosis is appropriate from a range of -10 to +10 when utilizing SEM. Brown 2006. For the reference value, we see that our data are more or less normally distributed, which is a safer side for researcher. Indicator correlations primary gives primary relationship among the data, and raw data file is exactly the same data entered in the earlier Excel file. No moderation model. Moderation analysis will be performed to assess the moderating role of JM between JS and JT. This example studied moderating effect through the following moderation model. Direct effect. JS to JT. Research objective 1. To find out whether job satisfaction causes turnover. Relevant alternative hypothesis 1. Job satisfaction causes job turnover. Another direct relationship JM to JT. To find out whether job market causes job turnover. Alternative hypothesis, job market causes job turnover, JM to JT. Now, indirect relationship, JS to JT, which will be moderated by JM. Research objective 3, to find out whether job market has a moderating role between job satisfaction and job turnover. Alternative hypothesis 3, job market has moderating role between job satisfaction and job turnover. Moderator JM between JS and JT. Let's build our model with the dataset. We need to double click on figure icon just below the PLS for no moderation model project in the Project Explorer. It shows no moderation PLS-SEM, which is an empty canvas, look like this. Double click here, empty canvas. The right click, then we find the design tool, which for simplicity we ignore for the time being. Please note that software button left show the indicator. Now we select together JS construct indicator JS1 to JS5 and drag into the canvas. Then right click latent variable to rename JS and select the indicator left. JS to J5. Rename it JS. Okay. Again, we select together gem construct indicator gem1 to gem8 and drag into the canvas. Then right click circle latent variable 1 to rename jm and select right indicator top. Jm1 to jm8, drag them together, rename at jm. Okay, then we put on the top. In the same way, we select together JT constructs indicator JT1 to JT5 and drag into the canvas. Then right click circle latent variable 1 to rename JT and select align indicator right. JT, okay, then select indicator to the right. We need to align as per our convenient and zoom. Okay. Align the construct and adjust the zoom as per your convenience. We connect JS to JT and then JM to JT by using connect tools and neutral the cursor by clicking select tool instantly. Connect tool from this one to this one, from this one and this one. Then we select to neutralize the cursor. Instantly, the model become green and it is ready for run. Now, we need to add moderator effect on the dependent construct JT. We will right click here, add moderating effect. Moderator variable is JM and independent variable is JS. Product indicator, standard and automatic. Then we set OK. So this is our moderating effect variable by product. We right click, we find everything. Okay. Now we rename it moderating effect JM moderating effect. We set okay. So this is our JM's moderating effect with product method. Now we need to prepare measurement model to check whether the model is fit for further analysis. If it is fit, then we prepare structural model to find our ultimate research objectives, the relationship construct with their respective significance level. Measurement model. Now we select calculate option, then PLS algorithm and select factor, then start calculation. Calculate PLS algorithm, factor, then start calculation. The report is being ready. We got the report. We find PLS algorithm run 1 for measurement model with main columns like final result, quality criteria, interim result, and base data. Under the subcolumn, we find our specific required values, outer loadings, construct reliability and validity, discriminant validity, etc. for the reporting in the following measurement model. We get figure 1 from this no figure. We right click here, export to image data file, then we can export here. I have done it previously, so I am ignoring it. This figure and this figure is the same. Now from PLS algorithm run 1, we will got the data. At first, factor loadings. This is outer loadings. From these loadings, we got the respective data, say GM1.744, GM1.744. For this product method, we need to ignore. We only take JM2, JM3, then JM4, JM5 from here. We put the data over here. And we find that all this data meet the threshold level of zero point 0.6, so we retain all the variables. Now we want to construct our reliability of this model. We got constant reliability and validity here, and this is the cron batch alpha, row alpha, and composite reliability. These are there. So this meet the threshold level. Now we will go for convergent validity. For convergent validity, we put the ABH variance extracted. We put the value over here except the moderating effect, which is shown in red. And we have seen that it has also reached the threshold level 0.5. Now discriminant validity, our first criteria is Cornell-Lorca criterion. These are the values except the moderating we put here. We see the diagonal value are higher than the non-diagonal value. Then for again another criteria is cross loadings. We got cross loadings over here. Except the product, we take the individual item value and put over there. We find that the cross loadings of the respective item is more on their respective construct rather than the other construct. So it also go for the threshold level satisfaction. Now discriminant validity, we need another criteria, HTMT ratio. This is the HTMT ratio except moderating effect, and it also reached the threshold level. So our decision is, given the aforesaid calculate values, the model is fit for further analysis toward structural model. Now structural model. After clicking this, we select calculate, bootstrapping, no sign, complete bootstrapping, bias corrected and accelerated bootstrap, two-tail test, 5% significant level. Then on partial least square option, we take path and start calculation. Smart PLS-3 is doing the calculation. As you see, it is on the progress. It will take a little while to prepare the report because it is running 500 samples and bootstrapping the feed indices. So it will take a little time. Like in our previous video, when the report is ready, we can collect this from the software to Excel file and from the Excel file to our reporting. That is shown in our earlier videos. So now the report is ready. From this bootstrapping run 1, we got final results, quality criteria, histogram, and base data. Under the sub-columns, we find our specific required values, R square and path coefficient for reporting. This is R square and this is path coefficient. So we need to export the figure. This is the export figure. Before that, we want to know the path coefficient and p-value for the respective data. For outer model, we can ignore for the time beings, and we'll highlight the part using the absolute values. So this is the beta coefficient and the significance level. Beta coefficient and significance level. Primarily, we can see that the moderating effect is insignificant. So there is no moderation. Now let's discuss it in detail. This figure and this figure is the same one. We have exported it from here to here. Our model qualities depend on the model's predictive capability and the path significance. As we see from there, our R square value, this is the value, we put it over here. We find that R square value is over 0.10 and it is statistically significant. Hence, the predictive capability was established. In addition, it means 42.2% variance in job turnover can be explained by job satisfaction and job market. So our predictive relevance is established. Now we go for path coefficient. This is the path coefficient. We see these are the values. We have copied it from here to here. And we find that our first hypothesis is accepted and also the second hypothesis with their significance level. But our moderating effect is insignificant. This is we put over there. You see the value is more than 0.05, the significance level we have chosen for this study. Now let's elaborate a little bit. We see the beta coefficient is negative, but our p-values is less than 0.05. And the confidence interval doesn't containing 0 also show the primary indication that the hypothesis is accepted. I am talking about alternative hypothesis. And same is true for H2. Details are discussed in these two paragraphs. Now the moderation analysis. These are the values minus 0.166 with the p-value of 46474 and it is not significant. So our decision is no moderation. Now we have to conclude. Following the aforesaid criteria, you mean criteria 1, decision criteria 1 and decision criteria 2. Moderation is absent when moderation effect of moderator on dependent constant was insignificant. Moderation present if moderation effect of moderator on dependent construct was significant. Now from this table we can see that it is insignificant. Therefore, following this aforesaid criteria 1, the moderating effect of job market on job turnover was insignificant. Therefore, there was no moderation in this model. As the job satisfaction increased, people leave their jobs irrespective of market condition. The job market condition, like job shortage or surplus, cannot make any significant impact on their decision in this case. Thanks for your time. I hope to see you in the next videos where we will show the presence of moderation effect. I think it is helpful. Thank you very much. Thanks for your time.